In this video, we are going to demonstrate how to take readings and proceed for calculations. Please be attentive. So let us start with the simulator that is given in the virtual lab for the magnetic field along the axis of a of a circular carrying current. Now coming to the simulator part, here we have set all the things what we needed. In the simulator you can see that we need to logged in here and given followed by some initial adjustment which is to be needed here, and after doing all the initial adjustment what we should escape in this video for sake of simplicity. Let's start from here. Now coming to this simulator, coming to the application part of this simulator, let me describe one thing, that you can proceed to the calculation in two ways. One way is to following this way. Say you have number of observation, you have a particular number of n, that means for example here I have mentioned some of them. For example, this is for n equals to 30, and I have kept that current by adjusting this rheostat value at let me show you this show normal. This is 0.556 ampere and it is there given here. So the r is the radius of the circular loop, that means this one I kept it at 10 centimeter, which is at highest. So x is 10 here. So for the left side it is the direct, and for the right side it is the direct and reverse also. So the thing is that how to take the data. So many people may face some problem. So there are two ways. One is, let's go to the theory part. So we have here equation number 3. This equation says that the Bx equals to nothing but B0 tan of theta. So if you have the B0 known to you, that means for this case it is given at 3.5 into 10 to the power minus 5 Tesla. You can proceed with this equation. If you know the B0, if you know the theta, for a different value of x, you will definitely know the value of Bx. So in this case the Bx can be calculated easily with the help of this equation. This is one procedure, and for that we have to follow this table. Say B0 is 3.5 into 10 to the power minus 5 Tesla. It is constant for a given current. For a number of radius it is given, it's a constant number of turns actually, that n, and the radius of the coil is r as the radius of the circular coil, to keep it constant. So what we have to vary is the distance from the center. So this can be varied. Deflection with the compass box on the left side, we take it as minus x, and deflection with the compass box on the right side we took it as plus x. And for calculating the mean theta in degrees, in the spreadsheet I will show you that I have made some modification in this mean theta. So while calculating this mean theta, what I have done, I have calculated the mean theta for the plus x side and for the minus x side. So there will be two thetas, one for the plus x, another for the minus x. Now similarly the Bx in the my modification, the Bx has been distributed in two parts. That means one is for minus x, another is for the plus x. I will show you shortly. And this Bx is calculated from the tan theta. So this is one way. So I will describe this way today to calculate the Bx values. Another way is direct way. The way is that if we go back to the theory, we can see that this Bx is nothing but given by this formula, that is mu 0 ni by 2 r square by x square plus r square to the power 3 by 2. Just what we have to do, we have to give this n, this I value, mu 0 value, r, and we have to give this variable value, this variable x value in this equation. We can easily get the theoretically the value of the bx. So in this simulator, the bx value actually follow this formula. Now coming back to the simulator, don't be actually confused with the data, that means the calculation given here. They have actually given this mean theta, this tan theta, bx and b0t. That is actually they have calculated this bx using that formula, using this formula, and then they have put this b0t by bx by tan theta to have the b0 value. But in this case we are going to have some modification. Let me show you that modification first. Here you can see that it's an Google sorry, not Google, it's an Excel spreadsheet. Let me describe the spreadsheet here. In this spreadsheet, in the first column, the B column is observation number, number of turns, I, this R value, that means the radius. I have converted this R in meters, this X also in meter, and you can see this left side, that means whenever the needle, that means the magnetic needle will be in the left side of the circular coil, we termed it as minus X, and this time that is right side as a plus X. And similarly we will find out the direct readings, and also by reversing the current we will easily calculate the reverse current for the theta for the reverse current reading. Now for coming to the mean theta value, let's say this is the for minus X we have a mean theta, that means we have to add them up and that's divided by 4, and this mean theta for the plus X we will add them together to have a plus X value. Now let's for the B0 we have keep it at 3.5 into 10 to the power minus 5 Tesla. Just be careful about the unit we have used here. Now let's go back to the work. Let's see what is happening in that part. Let's go back to the simulator. In the simulator portion we have set this let me zoom it in, let me keep it as per compass position at 0. So let me zoom the compass. Actually this is not in direct mode, it should be like this. So what we have for the 0 position, let me write it 0, and the position of the needle, as we can see, this is actually 71, and this is the theta 2, this is around 72. Reverse the current, this is 71, this is 72 again. Let's go back for the right side. So for 0 actually there is no left no right, whatever it is we have to just repeat that readings. Yes. So let it put down in the spreadsheet. Let me put it down in the spreadsheet. This is the spreadsheet here. So this is 556. One is direct reading will be 71. This is let me check again if it is so. 71. Yes, this is 71. Go to the spreadsheet. This is 72. This is 71. This is 72, 71, 72, 71, and this is 72. If we click here, it will give me the mean values for plus x and minus x. It will give me bx value for plus x side and as well as the minus x side. It is actually automatically generated. The calculation is actually, the formula is given here. You can see the formula. So please actually don't use this for the calculation. Don't calculate it in the Excel sheet. Please do calculate it in your by using your calculators. So let me go to back to it's okay, it's fine. 63937. I think I have done some mistake. This is yes, it's okay. Okay, done. Let's go for this one. Yes, this is using these two values, then it's okay, fine. Listen, enter. Now what we will do, this is going to be constant, this I is going to be constant, this R is also going to be constant. Now the X value will be, I will take for 4 intervals. For interval 4, this will be 0, 4. Don't take interval of 4. For you, you take the interval of 5. So for you it will be 5, 10, 15, 20 and 25. Or you can take for 3, 6. I think 3 will be fine. 3, 6, 9, 12, 15, 18, 21 and 24. You will have more data, more number of data. So it will be good practice to have a more number of data. You can go for the interval of 3. Actually these are in centimeters, so it should be 0.04. So yes, we should have to, now it's okay. So it's 24 centimeter, that means 0.24 meter. So everything is fine. Now let's go for the 4. So now we will go through the simulator and we will take the calculations in a paper and then we will write it down from here to here. Now let me go for the simulator part. Now I'm in with the simulator. So let me go for the position +4. So actually this is not actually reversed, direct. This is the direct. So I will explain you what is direct. So this is the direct. So this is my θ1 and this is the θ2. So we can see the values of θ1 and θ2. Now reversing the current, this is the θ1 and this is the θ2. Now what we have to do, we have to keep it as direct. Now I have to go for -4. Now this is the θ1, this is the θ2, this is the θ1, this is the θ2. Now I will reverse the current. This is the θ1 and this is the θ2. Now again we will keep it direct current. Now going for +8. So this is my θ1, θ2. For the reverse, this is my θ4 and θ3 and θ4. Now keep it direct, go to -8. So this is theta, actually this is θ5, θ6, θ7, θ8. Now keep it direct, go for +12. This is θ1, θ2, θ3, θ4. Keep it direct, go to -12, θ5, θ6. reverse the current, theta 7, theta 8. So if you want to reduce your calculation time or the data taking time, you can do one thing. Suppose we are in minus 12 centimeters. This is a trick. You can use it or you can't. It's up to you. So it's in reverse, so keep it direct. So I will take first the minus reading, negative reading first, because we already are in negative detection. So keeping it again in positive, then coming back to the negative, it will take 1 or 2 seconds more time. So it's a trick only. You may follow this or you may not, it's up to you. So coming to the minus 16, so be careful whenever you are going for minus 16, you take it for left side. When you are going for the plus 16, you are taking it the negative right side. So the thing is that we are taking all these things like this. Let me take this as minus x. Okay, so this is the theta 1, reverse the current. Sorry, no, this is the theta 1. I am sorry, this is theta 5, theta 6, well, this is think again. So we are at this minus 16 position. So this is the theta 5, this is the theta 6, this is the theta 7, this is the theta 8. So now I have to direct it, then going for the plus 16. This is the theta 1, this is the theta 2, reverse the current, theta 3 and theta 4. So likewise we can go for 20. So this is my theta 1, theta 2, theta 3, theta 4. I'm going, let's redirect it, then going to 20. So this is theta 5, theta 6, reverse it, theta 7, theta 8. Now direct it, go for minus 24. This is my theta 5, theta 6, reverse it, theta 7, theta 8. Now go to plus 24. I didn't reverse direct it, so I need to direct it. So this is my theta 1, theta 2, theta 3, theta 4. So whenever you are in positive side, keep it as theta 1, theta 2. Yes, no, sorry, I'm sorry. When you are in the left side, you take it as plus actually. This is actually plus. This is direct and reverse. So theta 1, theta 2, theta 3, theta 4, that will be calculated as minus x. But don't be confused with this minus. So for analogy, we have taken this minus as positive and this plus as negative. But for your simplicity, you can take this plus as positive and this minus as negative. So whatever it is, you please distinguish between these two values. Don't put the plus side value to the left side's value, or the negative side's value. So coming back to the Excel sheet, we have to write it down. So here we are writing it down, the values for the observation. So it's actually 67, 68, 67, 68, 67, 68, 67. Sorry. So we have noted down this value for the different x values, and you can see the theta 1, theta 2, theta 3, theta 4 values has been given using that by using that simulated data. Now we have calculated the mean theta for that one. We have calculated the mean theta for the x1 plus x side and minus x side. We have calculated for the bx for the plus x as well as for the minus x side. Now let's go for the graph portion, how the graph will look like. So before the graph we have to keep these things. So we are just taking this as positive x, so we are just keeping control C here, and this is control V. So these are for the positive x, so we have to select this, control C, and this is control V. Okay, something is so we are keeping it like this is 10 point. Let us write it down here. Okay, something is happening. Okay, let me write the values here. Control C, this is as okay, control V here. We just noting down this one. Now we have put the data like this. Suppose we have taken, as you can see, this is for minus x, all these values are for minus x. We have taken this as minus x, we have put 0 here, we can put 0 anywhere. So the thing is that you will just draw it this in the in a 1 mm graph paper, where you can see how it to draw it. You know how to draw it. So for an example, let us draw it in using origin. So this is 0, starting from 0 to uh, first of all minus 0.24, then from 0.4 to 0.24. We'll plot this one. Let's check how it will look like. So this is my origin. We'll put paste here. Okay, let me go again. So these are the values. So if we plot it, it is something like that. So we have to adjust all these things. So yeah, so now you can see the graph, design of the graph. So this is actually, as you can see, this is the peak. So it will be like, it will follow this line actually. So these are the points, you have to connect it. You don't connect actually the point wise point like this in a straight line basis. It will looks very different. It suppose if you connect this line with this line, this point to with this point, and from this point to this point, it will look like a triangle, but it shouldn't look like a triangle. It should be like this. It's a curved line. The line will pass through each and every point, but it shouldn't be joined like this, discrete. It shouldn't be like this. It should be like a continuous curve, not rather than a discrete curve. It should be continuous. It should be like this. So please maintain this one. I think you have uh, understood that what to do with this data and how to draw the curve. Now for example, this data is for the examples. Don't take this data directly from here. You calculate by using the formula, the b0 is equals bx equals to b0 tan theta. For particular this, for the theta value for this minus x, we have used this this tan theta actually, and for this plus x, the theta for the plus x value, we have used this theta only. So this is today for all for today. The thing is that I'm advising you to not to take these values. Take uh, 3 centimeter interval. Don't take 4 centimeter interval, because if you take it, it will be like this. So it will not be evaluated as your practical experiment. It will be regarded as a copy and pasted. So you just do one thing. You keep this as a 3 centimeter increment. Strictly obey this instruction, so that you will be able to do these experiments by your own, and thus accordingly the values will be different. Okay, so that's all for today. And in the next term, if you need, this is actually one type of the data measurement. So there are several data measurements techniques are there. We have used this bx equals to b0 tan theta here. So we can use that crude formula. That means it's given, let me show you. So in this formula you can see, to calculate the bx, you have to just put this values of mu 0, ni, this r square, this x square value, and all together you will find the value of bx. But here we have used this b0 tan theta. By use this theta value, we have calculated the bx value for several x's, and we have got this wonderful graph. Actually, it is given in this origin. So you just draw this graph using the 1 mm graph paper, and you will find that this graph will look like this. And try to use the whole graph. Don't actually use a small part of the graph, use full graph. And if you want to know how to plot a graph in graph paper, I will provide you in the next video. If you really want it, just please mention if you really need it. So that's all for today. If you like this video, you can subscribe this one also, so that I will be updated with the upcoming videos in the near future. Thanks for today. Thank you all.